decimals. A little different than yesterday's title. We did multiply decimals, but yesterday it was a decimal and a whole number. And today it's 2 decimals. The steps are going to be the same. You're going to multiply the 2 numbers as if there were no decimal points. And then at the end, once you're finished multiplying, we have to count some decimal places. Sean, do you need to move somewhere else that's less distracting? Need you to sit up a little bit more so that you can focus. There you go. So for today's lesson, since we're going to be multiplying 2 decimals, we do it like we would normally do it, and then we count those decimal places like I showed you yesterday. But instead of having just one number with decimal places, there's going to be 2. And then that total number is going to be how many decimal places will be in our product. Okay, but the multiplying part is going to be the same. So as we just talked about a minute ago, this is all similar to dividing and multiplying whole numbers. Difference is that we have to deal with the decimal point. And this is going to be one strategy that you can use when multiplying, because I'm going to show you how to do a model of one today, just so that you can have the picture in your head of what that would look like. And then if you'd like to use that way, you can. And if you'd like to use the standard algorithm, which is just the steps, then you can always use that way too. It's just another strategy. Everybody's different, remember. All right, so here's your problem of the day. It says a salad costs $2.59. Soup costs 98 cents, less than a salad. And a glass of milk costs 27 cents less than the soup. How much do a salad, soup, and milk cost all together? When you see less than, it means you're subtracting. So you're going to have to take the total cost of the salad and subtract 98 cents, and that amount is how much the soup will cost. And then it says that the milk
soup costs
98 cents less than a salad. And then a glass of milk costs 27 cents less than that. So you have to do them in that order. And then they want to know how much does a soup, salad, and milk cost all together. So if you're going to add them all together, so there's going to be some subtracting going on, and then also some adding at the end once you get all 3 amounts. So we're subtracting decimals and we're adding decimals. Try it again. So if the salad costs $2.59, the soup cost 98 cents. We're going to subtract, the soup is 98 cents less than the salad. So we're subtracting. This is the cost of the salad. And once we subtract, this is the cost then of the soup. And then it says that the glass of milk is 27 cents less than that. So that makes the milk $1.34.
That's not what it's asking now.
Not what it's asking. The question's asking how much would all 3 of those things cost together. So now we have to add them up. $2.59 for the salad, $1.61 for the soup, $1.34 for the milk. Right, because it says all together. So all together, everything costs $5.54.
Yes.
Give me a thumbs up. Did you get $5.54?
Yes.
All right.
Nope, not even close.
Here's what I got.
2 billion something.
Maybe you forgot some decimal points.
I got 4596475.
Nope.
This is what I got.
Did you get the right answer?
Yeah.
Okay. All right. Let's go on to the next one. That was... I'll wait until you're quiet though.
That's it. Now tell me so.
Cannot talk over your voices. So that was a review from chapter 5, because chapter 5 is where we added and subtracted decimals. So that was just a question to see if you remembered how to do that. So now today's in your notes for today. What? The questions for, here's what we're going to write in our notes. So chapter 6, lesson 5, here's the title of the lesson. It's just multiply decimals. And we talked at the beginning of this lesson how multiplying decimals was the same as what we did yesterday, except we have 2 decimal numbers instead of just 1. So I'm going to show you what the standard algorithm is, and then I'm going to show you one picture that will hopefully help you understand what it is exactly that we're doing. Okay? So first, we're going to write this again. Do not line up decimals. So you're not lining up your decimal points when you multiply. When you add and when you subtract, like in our problem of the day today, you did have to do that. But when you're multiplying, you do not line them up. Now sometimes they are going to line up just by accident. Like if both numbers go to the hundredths place that you're multiplying, then obviously your decimal points are going to line up. But sometimes you're going to have a number that's in the hundredths place and you're multiplying something that's to the tenths place, and then your decimals aren't going to line up and you're not going to make them line up. Okay? So let's do our first example. 3 3/10 times 75 hundredths.
Oh my God.
Hold on.
What's going on?
3 3. Nah. Try again. 3 3/10 times 75 hundredths. So just like we talked about yesterday, it's not necessarily going to be the biggest number, because remember, multiplication is commutative. You can multiply numbers in whatever order you want, and that counts for decimals too. So we're really looking at the number that has the most digits. So 75 hundredths has 3 digits in it. 3 3/10 just has 2. So I'm going to put the number with the most digits on the top. And you write the numbers as if there were no decimal points, because just like you just wrote, you do not line up the decimals when you multiply. So in this case, all we're going to do is start multiplying, and you kind of ignore that there's even a decimal there. Okay, and you're just going to do the multiplying. Yes, Tristan? You don't really need to do that when you're multiplying, because there's not going to be any open spaces, like maybe right here in the front of the 3, but you don't really need to have that number there. The reason why we annex a 0 before is because when we're adding or subtracting, you want to make it where you are actually adding a number like a 0, not a blank space. It's not necessarily the number that's bigger. It's the number that has the most digits. That's the number that makes it easier to multiply by. So sometimes that's something that we do, like, yes, because multiplication is commutative. So remember, commutative means that you can multiply in whatever order you want and you get the same answer. Just like when you add, you could do whatever order you want. All right, so some people had some problems with the double-digit multiplication yesterday, so pay really close attention. I'm going to start with the 3 that's in the tenths place all the way to the right, and I'm going to multiply that through with every digit on the top. So 3 times 5 is 15. I have to carry the 1. I'm regrouping that over to the next column. 3 times 7 is 21, plus 1 more is 22. 3 times 0 is 0. Then you add the 2. You have a 2 there. Now, what we did the first time we did this, because we've done double-digit multiplication, but it was without decimals. Same idea, though, right? I told you everything's the same. What we did then was we crossed out all the numbers we're no longer using. If you don't want to do that, you don't have to do that. But for some people who are struggling with this, it sometimes makes it a little bit easier so you don't reuse numbers by accident. And then you have to put a 0 underneath. Can't forget the 0, because if you forget the 0, that means when you add things up, you're going to be adding them up in you're going to be adding up the wrong numbers. So here's why. Now I'm going to this place, so my answer down here needs to start in the same place. If that helps you to remember. So we have to shift it over.
So it's the same thing as multiplication, just we have to go on this after you have to do the decimal.
Yes, it's exactly the same thing. The reason, though, yesterday some people had problems with the double digits. That's why I wanted to practice it. So now we do 3 times 5 again, which is 15. 3 times 7 is still 21, with 1 more is 22. We're doing the same math again because the numbers down here were the same. 3 times 0 is 0, plus 2 more is 2. And now we add them up. Now, here's the part that's new for today, because that was kind of like what we did yesterday. Now I have, watch what I'm counting. Anthony, look at the screen. This is the part that will be confusing if you're not watching. I have 1, 2, 3 decimal places in my question. So in my product or my answer, I will also have 3 decimal places. So I have 2 decimal places in this number, which what I mean is 2 spaces after the decimal point. And in this number, I have 1 space after the decimal point. 2 and 1 is 3, so my answer needs to have 3. And so I start at the back and I count forward 3 spaces. 1, 2, 3. So then my final answer is 2 and 475 thousandths. So just like we said yesterday, even if you write 2475 in that order, but you put the decimal in a different place, you're going to get the wrong answer because it's not equal to the same amount. Okay, that's important. Karnpreet.
Yeah, because me and Hamza both put the decimal after the 4.
Which was only 2. So that was kind of like, yesterday only one number had a decimal, so maybe you forgot. This number had a decimal too. So today you had one more. So 24 and 75 hundredths would be like $24.75. And this one's like $2.47. So that's a different amount. That would be like a, we don't do parts of cents, but if we did, that's what that would be. So about $2.47. There's a difference. All right. Let's do another one. Another example. 2 and 7 hundredths times 9 and 1/10. So, like Bryson brought up on the last question, 9 and 1/10, that's a bigger number, isn't it? Like if you were comparing those numbers, that's 9 holes, and the other one only has 2 holes. But we're not looking at which number is bigger. We're looking at which number has the most digits, and that's the one that's going to go on the top. So 2 and 7 hundredths is what's going to go on top. 9 and 1/10 will go on the bottom. That's the number one way where people get confused on this, is because they flip-flop the numbers, and then when they go to multiply, they aren't sure what to do because they have in 3 digits on the bottom and only 2 on the top, and it's because you should have flipped them. So remember, you could do it in whatever order you want. So I'm going to finish solving. I want you to solve on your paper and then look up and see if we got the same answer. Okay, so let's see. I hear some people I hear saying that they got the right answer. Other people I see going, oh, what? And then they go, oh, because they look at what I did and what they did. So here's what I did. I started here with the 1, and I multiplied 1 times 7. Then I multiplied 1 times 0. Then I multiplied 1 times 2. Then I put this 0 under here. Remember, you cannot forget about putting the 0. That's annexing a 0 before you start the next line. Then I did 9 times 7, which is 63, so I carried the 6, put the 3 underneath. 9 times 0 is 0, plus 6 is 6, and 9 times 2 is 18. Then I added them together. 7, 3, 8, 8, 1. And then here's where I found out where my decimal point would be. 2 decimal places in this number, and 1 in this number, makes a total of 3. So I would have 3 decimal places. So the decimal point is 3 spaces from the end in my answer. So I got 18 and 837 thousandths. Yes.
First I thought 9 times 7 was 72 because I got the 7
yes, the
mixed
basic
up.
facts are going to mess you up.
Then I carried it to the wrong place when I got the right thing, and now I got it right.
All right, as long as you see what you did, that's the important part. Let's do one more example. One more example. 1 and 6/10. 1 and 6/10 times 4 and 3/10. 1 and 6/10 times 4 and 3/10. Doesn't matter which number you put on the top. There's 2 digits in both numbers. So it doesn't really matter. I'm going to put this one on top just because that's the bigger number.
Me too.
So, but you could do it the other way and you get the same answer. So you solve, I solve, you check up here.
It's a 4.
So would it be the same thing if you wrote this?
No.
Same answer? Would this be the same answer? Is this the same answer as this? Is that would be the number one? Oh wait. That would be the number one wrong answer, because what happens is when the decimals do line up like this, what people want to do is just drop it down like that into their answer and put it right there. But remember, you have to count the decimal points. When you're adding, that's what you do. You just drop it right down, or subtracting. When you're multiplying, you have to count up those decimal places. Okay, let's look over at your assignment. Look over at your assignment. All right, here's the question. Nina's buying peanuts in bulk. The peanuts cost 75 cents for each pound. She purchased 2 1/10 pounds of peanuts. How much will Nina pay? And then it asks you to round to the nearest cent. So here's what that means, because you may see that on your assignment today. Remember when we had a question that was 2.475 or something like that, and I said that's like saying $2.47. Cents goes to the hundredths place, right? We don't use thousandths place in money. So if it goes to the thousandths place, they want you to round it to the nearest hundredth. Okay? So just, if they say that in the directions, that's what they mean. So we're going to multiply 75 hundredths times 2 1/10. Lucky for us, they already wrote this over here. So they already started it for us. Because 75 cents, 75 hundredths, has more digits, we're going to put that one on the top. And then we start to multiply. 1 times 5 is 5. 1 times 7 is 7. 1 times 0 is really 0, so if you were writing that in, there's no box for it, but it's because it's a 0. Then you put a 0 underneath. We can mark out this 1 here. And now we're going to start multiplying with the 2. 2 times 5 is 10. 2 times 7 is 14. Then we add the 1 on the top is 15. 2 times 0 is 0, plus 1 is 1. Then we can add those up. So we have 5, 7, 5, 1. This right here is the part that's new for today's lesson. That's the part I want you to keep your eye on. The top number has 2 decimal places and the bottom number has 1. So that means that your answer would have a total of 3. 1, 2, 3. So your answer is 1 and 575 thousandths. Now remember what the direction said. It said that if it goes to the thousandths place, you're supposed to round it to the nearest cent. So 1.575 we really, when we talk about money, we don't need this last digit here. So we're going to round to the hundredths place. So because I underlined the 7, and when I look to the right, that's a 5. Since it's 5 or more, that means that the 7 gets upped by 1. So then your final answer would be $1.58. Because 1 and 575 hundredths is not an amount when you're talking about money. And we were talking about money because the question was about buying peanuts. And so how much would they all cost? So that's why we had to round that. On here they estimated 75 cents up to $1, and they rounded 2 1/10 down to 2. So our estimate should be about $2, which is almost what we have. Here's where I rounded it. Fill that in, please. So Nina needs to pay $1.58, and $1.58, if you rounded it up, would round up to $2. So it's about $2. Look at example number 2. DeMarcus is buying a new guitar pick. It costs 50 cents. Cost 50 cents. The sales tax is found by multiplying the cost of the guitar pick by 6 hundredths. What's the cost of the sales tax for the pick? So if we estimate 50 cents and we round it up to $1, and then we say 6 hundredths is almost nothing, so we rounded that down to 0, would be about 0. So that means that when we get our final amount, it's going to be closer to 0 than it is to $1. So if we thought of a number line, it's going to be something that's way down closer to the 0 than it is to the 1. Okay, so we're going to multiply as with whole numbers. So we're going to multiply just like we were if we had whole numbers. So we have a 0, 30, then a 3, because 6 times 0 is 0, plus 3. Then here's where this one is a good example, because I didn't have one of these in our notes. 2 places on 50 cents. 2 decimal places here on 6 hundredths, right? So that means our answer should have 4 decimal places. But look what happened. 1, 2, 3, 4. Our answer only had 3 digits in it, but they wanted us to count backwards 4 spaces. So we need to add a 0 into the place that it's created.
If you didn't have the 0, it'd be wrong.
Right. If you didn't have the 0, your answer would be like 30 cents instead of 3 cents. Because really these zeros now we don't need, so we could cross them out. So our total amount would be 3 cents. So the tax on a guitar pick that costs 50 cents would be 3 cents.
What? That's called 3 cents.
Right, that's the tax on something that costs 50 cents. So it would be, so the sales tax, really our answer looked like that with the 2 zeros on the end, but we took those off because you don't need them after the whole number. And the product, 3 cents, is close to 0, which was what our estimate was. Like if we looked at a number line and down here was 0 and up here was 1, 3 cents would be like way over here. So that's why we're saying it's closer to 0 than it is to 1, and that was our estimate, so that works. Okay, you're going to have to take a couple of minutes to look at the guided practice. Now today I want you to pay, when you go back and look at your answer, so once you solve the problem, think you have an answer, I want you to do one extra step. I want you to look back at the question again, count the decimal places one more time, and make sure that your decimal's in the right spot. Because that's where people are going to make mistakes. And on our tests, you don't want to make that mistake. You don't want to accidentally put the decimal in the wrong place to be the reason why you get the question wrong. So take an extra second just to double check, make sure your your decimal's in the right place on your answer. Okay? So take a couple minutes to work through 1 through 3, check them with a neighbor, then you can start independent practice.